Hello students, today we begin with the chapter of alternating currents. For the sake of convenience, we have divided this entire chapter into 3 lectures. And in the first lecture today, let us introduce ourselves to the basic terminologies related to alternating currents, such as what is the meaning of average value of EMF, what is the meaning of RMS value of EMF, and so. We have already set up the background of alternating currents at the end of our discussion in the chapter of electromagnetic induction. If you remember there, we had said that in case a coil is rotating inside a magnetic field, then the EMF induced has a sinusoidal variation. And essentially we were calling it alternating EMF. If it is converted into currents, then we were calling it alternating current. If we look at the sinusoidal variation of the EMF or current, you can plot EMF as well as current on vertical axis. Right now, let us suppose I have plotted the current and its variation with time. You have already seen it was having this kind of variation and it was contouring for long. Understand? The time it takes to complete its one cycle, that is called time period. Let us suppose the rotational speed of the coil in the magnetic field was omega. Then this omega was related to time period as 2 pi upon capital T. This was the correlation between the circular frequency. Now the omega will not be called angular velocity, rather it will be called angular or circular frequency, and the unit will be radian per second. If you consider the realistic situation in India, then you know that the rotors here, everywhere, wherever electricity is getting produced, whether it is hydroelectric power plant or gas power plant or nuclear power plant, the turbine is rotating 50 times a second. For that matter, you can say the value of omega in realistic situation is 2 pi into 50 radian per second. जब वो 1 सेकंड में 50 times rotate करेगा, तो उसके basis पे you can calculate what is the frequency, what is the time period, everything can be calculated. Now, whatever graphical representation you have here, if you try to show it with the help of a circuit diagram, then you can say that a resistance R, let us suppose it is connected to an alternating EMF. The alternating EMF was denoted as E naught sin omega t, and that was getting converted into current which is flowing through this resistor. Here you cannot show the direction of the current. जो अल्टरनेटिंग ईएमएफ है उसमें आप करंट की डायरेक्शन या ईएमएफ की डायरेक्शन नहीं शो कर सकते एज यू आर शोइंग इन डायरेक्ट करंट, बिकॉज हियर ऑल द टाइम यू कैन सी द करंट इज चेंजिंग इट्स डायरेक्शन एज वेल. इफ यू ट्राई टू एनालाइज दिस ग्राफ मीन्स दैट फर्स्ट द वैल्यू ऑफ करंट थ्रू द रजिस्टर इंक्रीजेस. जैसे आप यहां देख सकते हैं करंट 0 से सम मैक्सिमम वैल्यू आई नॉट एक्वायर कर रही है in a particular direction, then in the same direction the value of current is going down. तो current पहले मान लीजिए इस direction में start हुई, the current has acquired its maximum value in this direction, then in the same direction the current is decreasing and coming back to the value 0. इसी direction में current की value अब 0 हो गई. Now the current is flowing in this circuit in reverse direction. Reverse direction is being plotted here on the downward side in this graph. So यहाँ पे current अब reverse direction में आ रही है. रिवर्स डायरेक्शन में इट इज एक्वायरिंग अ मैक्सिमम वैल्यू. जितनी वैल्यू ये अपवर्ड डायरेक्शन में उतनी ही डाउनवर्ड डायरेक्शन में, दैट मीन्स फॉरवर्ड डायरेक्शन में करंट की जितनी मैक्सिमम वैल्यू है, सेम वैल्यू इट इज एक्वायरिंग इन रिवर्स डायरेक्शन, और फिर रिवर्स डायरेक्शन की करंट फाइनली जीरो हो रही है. So current one time flows in this direction, then forward, then reverse. That is why you are calling it alternating current. Now the problem here is that current is neither constant in magnitude nor in direction. If you try to compare alternating current with direct current, then in direct current, once you were mentioning the value of current and the direction, our answer was complete. Because वहाँ पे मैग्नीट्यूड कांस्टेंट होती थी, डायरेक्शन भी अगर आपने स्पेसिफाई कर दिया तो हमारी सारी इंफॉर्मेशन कंप्लीट हो जाती थी. बट हियर द ऑल्टरनेटिंग करंट इज नॉट कांस्टेंट इन मैग्नीट्यूड nor in direction, so you will have to find out some alternate ways in which you can express alternating currents in terms of magnitude and direction. Before we discuss all these things, remember that why we produced alternating currents, because it has certain advantage over direct current. There are certain advantages which are clubbed with direct current, there are certain advantages that is clubbed with alternating currents. You can compare. The major advantage of alternating currents is that the transmission losses are very less. You understand? The major advantage of alternating current, that I am writing AC over direct current DC, is that transmission losses are less in AC. What is the meaning of transmission losses? Remember that wherever electricity is produced and wherever it is consumed, उन दोनों के बीच में काफी डिस्टेंस होता है. The plant where you are generating electricity is quite far off from city areas. You understand? City area से वो काफी दूर है. Therefore, you have to join cables from the point of production of electricity to the point of consumption of electricity. और उस प्रोसेस में जो करंट हमारी वायर में फ्लो कर रहा है, इन केस यू विल बी फ्लोइंग डायरेक्ट करंट इनटू दैट वायर, द ट्रांसमिशन लॉसेस विल बी वेरी मच, मोर देन 90% इवन. बट इन केस ऑफ ऑल्टरनेटिंग करंट्स, it has been our experience that transmission losses are around 50%, not much. And this is the major advantage because of which you are producing alternating currents. It is not as such that we cannot produce direct current. We can, but we are producing alternating currents. We are bringing it in our home, and let's suppose some appliance is running on DC, then we have some other arrangement in which AC can be converted into DC. That becomes the part of our discussion when we go to semiconductor electronics chapter. But right now, remember that this is the major advantage because of which we have produced alternating currents, and that is why we are trying to discuss the various properties of alternating currents. Now, as I was saying, that the alternating current is not constant in magnitude, it is not even constant in direction. So to define its magnitude, we have two ways. One way is called the average value of current, because you see, whenever you are dealing with current, either you are interested in calculating the value of charge it is flowing in a particular circuit, or you are interested in this fact that what is the amount of heat it is generating in the circuit. You understand? कोई भी करंट से रिलेटेड अगर आप सर्किट डायग्राम देखें तो हमारा मेन पर्पस ये जानने का होता है कि ये करंट उस सर्किट में कितना चार्ज फ्लो कर रहा है, ये करंट उस सर्किट में कितना हीट जनरेट कर रहा है. सो व्हेनेवर you are interested in knowing about a quantity which is related to charge flow, then we talk about average value of current. And whenever you are interested in knowing what is the amount of heat it is generating in a particular circuit, then we happen to be concerned with called RMS value, or you have already known this term, root mean square value of the alternating current. So first let us discuss what is the meaning of average value of an alternating current. We should know what is the meaning of average value of an AC. To understand the meaning of average value, try to understand that you have a circuit in which an alternating EMF is connected. Let us suppose the resistance through which the current is flowing is R. The current which is flowing here imagine that this is given as I naught sine omega t. This I naught is the peak value, or you can say magnitude of the current which is flowing in the circuit. And simultaneously, imagine that you have another circuit which is connected to a direct voltage source in which the current flowing is I, and you are calling it I average. You will find that the average value of a current has symbolic representation. You can call it I average. एवरेज के लिए हमने सबस्क्रिप्ट यहाँ पे AV यूज किया है. सो ट्राई टू कंपेयर दीज टू सर्किट्स. यहां पे आप देख सकते हैं कि इस सर्किट में एक एवरेज करंट फ्लो कर रही है और यहां पे एक ऑल्टरनेटिंग करंट फ्लो कर रही है. इफ यू गेट डाउन टू दिस पर्टिकुलर डायग्राम, यू कैन से दिस मच टाइम इज हाफ ऑफ द टाइम पीरियड. ये पूरे ऑल्टरनेटिंग करंट की एक हाफ साइकिल है और ये सेकेंड हाफ साइकिल है. इन फर्स्ट हाफ साइकिल यू विल फाइंड दैट वट एवर इज द डायरेक्शन ऑफ करंट, सेकेंड हाफ में करंट की डायरेक्शन बिल्कुल रिवर्स हो जाएगी. देयरफॉर अगर हम एक पूरे साइकिल में चार्ज फ्लो की बात करें तो जितना चार्ज फर्स्ट हाफ साइकिल में लेफ्ट टू राइट डायरेक्शन में फ्लो करेगा, सेम अमाउंट ऑफ चार्ज विल बी फ्लोइंग in the other half cycle in reverse direction, and net charge flown over a cycle will become zero. Therefore, average value define करने के लिए we happen to concentrate only on the half cycle of any particular alternating cycle. You understand? So here, for the sake of defining the average value of an AC, we happen to say that whatever amount of charge is flown by an AC over its half cycle, if same amount of charge is flown by some constant current through the same circuit, then that constant current is called average value. So the definition is average value IAV of an AC is that much constant current which will flow same charge as the AC will do over its half cycle. You understand? This is the formal definition of average value of an alternating current. Let us try to understand what we have written here. It says that average value of an AC is that much constant current. Here you can say I average, I have shown like a constant current. एक डायरेक्शन भी हमने यहाँ पे शो की है. इस ऑल्टरनेटिंग करंट को हाफ साइकिल में अगर आप कॉन्सेंट्रेट करें, वाई हाफ साइकिल? बिकॉज इन हाफ साइकिल द चार्ज विल बी फ्लोइंग इन वन पर्टिकुलर डायरेक्शन. तो ये हमारा एसी एक हाफ साइकिल में जितना चार्ज फ्लो करेगा उतने ही टाइम में ये एवरेज करंट भी उतना चार्ज फ्लो करेगा, एंड देन दिस कांस्टेंट करंट विल बी कॉल्ड एवरेज करंट. इफ यू गो बाय दिस डेफिनेशन, then for the sake of derivation of this average value, what you have to do, you have to equate the charge flown in both the circuits. You understand? For the sake of derivation of this, you can for the sake of deriving this is understood that दोनों जगहों पे resistance same होगी, circuit same रहेगा, and time interval which you will be taking that will also be same. Now try to concentrate how much amount of charge will be flown by this alternating current over its half cycle. Then you will say this will be equal to, ये करंट की इंस्टेंटेनियस वैल्यू है I नॉट साइन ओमेगा टी. आप ऐसा समझे कि there is a very small time interval, say call it dt. So if you are multiplying this instantaneous value of current with this small time interval dt, then this product gives you the small amount of charge which has been flown by this alternating current over the time interval dt. and now you are interested in integrating it from t is equal to 0 to half of the time period, because आपने यहां पे सिर्फ हाफ साइकिल को कंसीडर करना है. To understand? So this is the expression of charge flown due to this alternating current over its half cycle. And if you try to consider what is the charge flown by this constant current, which you are calling average current, since this is average current or constant current, so simply अगर आप करंट को टाइम इंटरवल से मल्टीप्लाई कर देंगे तो वहां का चार्ज फ्लोन कैलकुलेट हो जाएगा. सो अगर आपने इसको हाफ ऑफ द टाइम पीरियड से मल्टीप्लाई कर दिया, सो दिस विल बिकम द चार्ज फ्लोन बाय अ कांस्टेंट करंट. यू अंडरस्टैंड? हमने जो डेफिनेशन में बात लिखी थी कि दिस इज दैट मच अमाउंट ऑफ चार्ज which is flown by alternating current over its half cycle, and this is same charge which the average current or constant current will flow over the half cycle time period, that is t by 2. Now if you integrate this thing, then you will find, you can correlate all these things, you can do the derivation, and you can get the value I average is equal to 2 I naught by pi. You understand? In case you do the derivation of this thing, you will be able to integrate sin omega t, that will become minus cos omega t upon omega, और फिर आप इसको जब correlate करेंगे तो you will getting this kind of expression. Now on the similar line you can also define what is the average value of EMF. जैसे हमने ये average value of current define किया है, on the similar line you can define what is the average value of EMF. For that thing you can say E average, that will also become equal to 2 E naught. What is E naught? E naught is the peak value of EMF. You understand? अगर इस जगह पे करंट की बजाय आप EMF लिख रहे होते, it's one of the same thing. You understand? Average value of current will follow 2 by pi factor. The average value of EMF will also follow the 2 by pi factor. I naught is the peak value of current. E naught is the peak value of EMF. So this is the way you will be able to derive what is the average value of an AC. You understand? Now, what is the use of this average value? This will be helping you to calculate the value of charge flown in the circuit. Now, on the similar line, you can define what is the RMS value of an AC. Why RMS? Because कभी-कभी हमें जब सर्किट में टोटल चार्ज फ्लोन की जरूरत पड़ती है, टोटल हीट जनरेटर की जरूरत पड़ती है, तब हम RMS वैल्यू को यूज करते हैं. सो लेट अस डिफाइन व्हाट इज द RMS वैल्यू ऑफ एन ऑल्टरनेटिंग करंट. Let us define the RMS value. RMS value of an AC. RMS means the root mean square value. Now at this juncture, the method of defining RMS current will follow the same principle as you have for average value. You see, again consider this particular circuit in which an alternating current is flowing. For the sake of defining average value, you were concentrating on the half cycle, but for the sake of defining RMS value, आप चाहें तो हाफ साइकिल ले सकते हैं, आप चाहें तो कंप्लीट साइकिल ले सकते हैं. द मोर कन्वेंशनल थिंग इज दैट वी हैपन टू टेक द कंप्लीट साइकिल, बिकॉज अगर हाफ साइकिल देखें तो करंट इस डायरेक्शन में फ्लो कर रहा है, नेक्स्ट हाफ साइकिल देखें तो करंट रिवर्स डायरेक्शन में फ्लो कर रहा है. बट वट एवर मे बी द डायरेक्शन ऑफ करंट फ्लो, हीट विल ऑलवेज बी जनरेटेड, क्योंकि हीट की कोई डायरेक्शन नहीं होती. चार्ज फ्लो में डायरेक्शन होगा, बट द हीट फ्लो विल नॉट बी हैविंग एनी डायरेक्शन. देयरफॉर, फॉर द सेक ऑफ सिंप्लिसिटी, definition of RMS value involves the heat generated in total cycle, not half cycle, rather complete cycle. So अगर RMS value को देखें तो we happen to say that RMS value is that much constant current. RMS value is that much constant current which will flow the same heat as the AC will do over its complete cycle. जितने complete cycle में AC की heat generate होगी, same amount of heat will be generated by this constant current over the same time period, that is capital T. So you define it as RMS value, or you call root mean square value. RMS value of an AC is that much constant current which will generate as much heat as the AC will do over its complete cycle. यहां पे हम कंप्लीट साइकिल टाइम पीरियड की बात करते हैं. यू अंडरस्टैंड? आरएमएस वैल्यू ऑफ एन एसी, आरएमएस वैल्यू इज दैट मच कांस्टेंट करंट. यहां पे आरएमएस करंट जो हमने लिखा है ये बेसिकली एक कांस्टेंट करंट की नोटेशन है. इट इज दैट मच कांस्टेंट करंट विच विल जनरेट एज मच हीट. हीट जनरेशन का फॉर्मूला अगर आप याद करें, इट वाज आई स्क्वायर आर इंटू टाइम. आई स्क्वायर आर वॉज द पावर. ये सारी बातें हमने हीटिंग इफेक्ट या थर्मल इफेक्ट्स ऑफ करंट में देख रखी है. सो इट इज दैट मच करंट जिसकी हीट जनरेशन ओवर द कंप्लीट साइकिल उतनी ही होगी जितनी की एसी की होगी ओवर इट्स कंप्लीट साइकिल. नाउ बेस्ड ऑन दिस डेफिनेशन यू कैन डिफाइन and you can obtain the expression of RMS value of this AC. Let us do that. If you go by the definition of this, then you should remember that the heat generated by this is square of this is current square. Since the resistance is R, you are writing here R, and imagine a very small time interval say dt. तो इस dt time interval में ये इसका heat generation होगा. If you talk about the heat generated by this alternating current over a very small time period say dt, तो यहाँ पे heat generated इसका I square R dt इस तरीके से लिया जाएगा. And you are considering the complete cycle, so in complete cycle it will be integrated between 0 to capital T. इस पूरे टाइम पीरियड में जितना भी हीट जनरेटेड होगा दैट कैन बी इक्वेटेड लाइक दिस. एंड दिस हैज टू बी इक्वेटेड बाय हीट जनरेटेड थ्रू दिस रेजिस्टेंस बाय दिस कांस्टेंट करंट दैट इज बीइंग कॉल्ड आरएमएस करंट. सो आरएमएस करंट सिंस इट इज अ कांस्टेंट क्वांटिटी, सो यू आर सिंपली राइटिंग इट स्क्वायर इनटू द रेजिस्टेंस एंड द टोटल टाइम पीरियड दैट इज कैपिटल टी. यू अंडरस्टैंड? यू हैव टू कैरी आउट दिस पर्टिकुलर एक्सरसाइज. यहां पे साइन स्क्वायर ओमेगा टी की इंटीग्रेशन इन्वॉल्व है. दैट इज अ स्टैंडर्ड इंटीग्रेशन दैट कैन बी रिटन एज 1 माइनस कॉस 2 ओमेगा टी अपॉन 2. और फिर जब आप इसको इंटीग्रेट करके सिंप्लीफाई करेंगे तो यहां पे आरएमएस वैल्यू बहुत ही सिंपल सी एक्सप्रेशन आई नॉट अपॉन रूट 2 के इक्वल आ जाएगी. 1 बाय रूट 2 की वैल्यू अप्रोक्सीमेटली 0.707 भी होती है. सो this can be used as RMS value. On the similar line you can define the RMS value of EMF as well. अगर एक EMF की RMS value लेनी होगी, let us suppose EMF is the alternating EMF, तो उसकी RMS value के लिए you can define it as E naught upon root 2. Whether it is current or whether it is EMF, दोनों के लिए RMS value same standard notation 1 by root 2 में use हो जाएगी. You understand? Now this RMS value is sometimes also called virtual value or sometimes it is also called effective value. And for the sake of simplicity also remember that in a question let us suppose nothing is mentioned. आपको let us suppose कोई value 220 दी गई है, then you have to understand this is the RMS value which has been given in the question. You understand? So now once we have defined this RMS value and average value, we can try to represent how the instantaneous value of an EMF or current can be generated. Let us see that with the help of a demonstrating example. Let us consider an example which is trying to demonstrate the RMS value of an alternating EMF. The example demands that write down the instantaneous value of value of alternating EMF of 220 volt 50 hertz. You understand? इस तरह से हमें एक डेटा दिया हुआ है. You have an alternating EMF जिसकी वैल्यू 220 वोल्ट एंड 50 हर्ट्ज दी हुई है, एंड यू आर एक्सपेक्टेड टू राइट डाउन द इंस्टेंटेनियस वैल्यू ऑफ दिस EMF. व्हाट इज द मीनिंग ऑफ इंस्टेंटेनियस वैल्यू? इंस्टेंटेनियस वैल्यू मीन्स इट शुड बी रिटन डाउन एज अ फंक्शन ऑफ टाइम. मतलब इसमें आपको E नॉट साइन ओमेगा टी या E नॉट कॉस ओमेगा टी के फॉर्म में इस डेटा को रिप्रेजेंट करना होगा. इंस्टेंटेनियस वैल्यू will be written as E नॉट साइन ओमेगा टी, और अगर आप चाहें तो इसको E नॉट कॉस ओमेगा टी के फॉर्म में भी लिख सकते हैं. दोनों ही एक्सप्रेशन जो है इसकी इंस्टेंटेनियस वैल्यू कहलाएगी. इट इज मोर कन्वेंशनल टू राइट इन टर्म्स ऑफ साइन रादर देन इन टर्म्स ऑफ कॉस. नाउ यू रिमेंबर दैट दिस E नॉट इज द पीक वैल्यू. अगर आप यहां पे 220 वोल्ट की बात करें, एज आई हैड सेड दैट इफ नथिंग इज मेंशन्ड in the question, then you happen to consider that value to be the RMS value. So here you have been given ERMS, जो यहां पे आप 220 वोल्ट का डेटा देख रहे हैं. This 220 volt is essentially the RMS value, and if you try to correlate it with the peak value, then this is equal to E naught upon root 2. You understand? So for that matter, you will find that the peak value E naught will be written as 220 root 2 volt. Understand? The peak value of EMF will be written as 220 root 2 volt. Now the next part of the question demands that what is the value of omega, because if you want to express your answer in these terms, then you should know the value of E naught and you should know the value of omega. The value of E naught is 220 root 2, you have already obtained, and omega, if you want to calculate, this is equal to 2 pi into frequency. This frequency f will have the unit hertz, and this frequency omega will have the unit radian per second. In this question you have been given this f, you can see 50 hertz, this is the value of this small f, and you are expected to calculate the value of omega. Therefore what you have to do, you have to multiply this by 50. You have to multiply this by 50, and this becomes 100 pi radian per second. The unit will be 100 pi radian per second. You understand? यहां पे E naught की वैल्यू वोल्ट में आ गई और ओमेगा की वैल्यू रेडियन पर सेकंड में होनी चाहिए. Now once you substitute these two values here, the value of E naught and the value of omega into this expression, then your final answer will come out to be, either you can write it as 220 root 2 sine 100 pi t, or you can write it as 220 root 2 cos 100 pi t volt, because this is the EMF you have expressed. You understand? This is the way things are correlated. जो भी आपका डेटा दिया हुआ है वो डेटा पीक वैल्यू में नहीं है, इंस्टेंटेनियस वैल्यू में नहीं है. दिस इज इन टर्म्स ऑफ RMS value, and RMS value and frequency have been converted for E naught and omega, and finally they have been expressed in terms of time. जैसे ही हमारे फंक्शन में टाइम इन्वॉल्व हो जाता है, then it is called instantaneous value as a function of time, you can say. Here in this question we have expressed it in terms of voltage. In case the question demands and you are expected to write in terms of current, that also you can do here. So this is the way you have tried to define the magnitude of an alternating current. जैसे हमने कहा था कि करंट ऑल्टरनेटिंग करंट की मैग्नीट्यूड फिक्स नहीं होती, तो ऑल्टरनेटिंग करंट के मैग्नीट्यूड को एक्सप्रेस करने के लिए यू आर टू वेज, आइदर इन टर्म्स ऑफ एवरेज वैल्यू और इन टर्म्स ऑफ आरएमएस वैल्यू. Now the question arises that how will you express the direction of alternating current? Then the suitable convention we have chosen for defining the direction of current is related to phase, lag or lead. So let us discuss that.